Hello, this is Barry Evans with Penn State University. In this unit, we will take another look at the loads that we generated using the GWLFE model in the previous unit. Specifically, we will look at the mean annual loads for the Big Hollow subbasin that we had created using GWLFE, and then we will look at these loads within GWLFE. Also, we will use something called the Urban Area Viewer, which will allow us to take a look at the loads not only for the entire Big Hollow subbasin, but also the estimated loads for that portion of the Big Hollow that more or less represents our MS4 area. These are the loads that we will be responsible for in terms of developing a watershed improvement plan. This next slide is one that we've seen before. As explained in the introductory material to Unit 8, we are going to assume that we are working on behalf of Patton Township. As you can see, the township covers about a little more than a third of the Big Hollow watershed. And what we will do is concern ourselves with developing a watershed improvement plan that addresses the pollutant loads originating from Patton Township to the Big Hollow watershed, which has been deemed to be impaired. As mentioned earlier, the US EPA has developed an urban area layer, which is intended to represent those MS4 areas within any given municipality. As shown on this map, there are actually two urbanized areas located within Patton Township, only one of which is in the Big Hollow watershed. Since we loaded the urban area layer into MapShed as part of our last analysis, loads have been calculated both for the Big Hollow subbasin as well as each of the urban areas within the subbasin. It is these loads that we are able to see using the new Urban Area Viewer. Okay, so let's take another look at that model output data that we generated in the last exercise. As we did in the last exercise and in previous exercises, we accessed the GWLFE model form to look at input and output data through the MapShed interface. We did this by clicking on the GWLFE button in the interface. However, it's also possible to open the model directly by double-clicking on the model executable. Again, under MapShed, there is a folder called Models, and this contains all of the models that can be accessed through the MapShed interface, including the GWLFE model. So we can just double click on this and then click on Run to open up the model. So let me just minimize this screen and back. So we can either open up an input file or open up an output file. We've already run the model, so let's take a look at the output that we've already generated for the Big Hollow watershed. Click on Average Output, and again, by default, the model assumes that we're going to be looking at the metric output because it was initially a metric model, but we can also look at the output in English format, which we will do now. So to get the output, we click on the Browse button, and if you recall, we ran the model and put the output in a subfolder called Run Files and another folder called Big Hollow, and once we ran the model, everything was put into another output folder, in this case called Output. So this is the output for the Big Hollow 7238. So if we double click on that, we can then view the output. We can look at the hydrology, the monthly loads, and the loads by source. And we did this briefly in the last exercise. So what we want to focus on in this case is, again, the sediment. So let's look at the value for sediment. This is for the entire Big Hollow watershed. So the sediment here that was generated, or at least estimated to be generated within the Big Hollow watershed on a mean annual basis, was 2,625.7 tons of sediment. Now, what we'd like to do is take a look at that in pounds. So I'm going to take that value 2625.7 and multiply that by 2,000 to calculate pounds of sediment. So within the Big Hollow watershed, the model estimated that on a mean annual basis, 5,251,400 pounds of sediment are generated by different sources within the Big Hollow watershed, including agricultural sources, urban sources, stream bank erosion, etc. So this new load, this new sediment load, essentially represents the new baseline load for sediment for the entire Big Hollow watershed. While it's useful to know this, we're really more interested in knowing what portion of this total load is contributed by the urban area, the MS4 area, within the Big Hollow watershed. To ascertain this, we need to go to the urban area viewer and load the same data within that form. So to do this, let's first minimize the calculator and then close out of the GWLFE model interface. We'll go back to the directory where the models are stored. In this case, the MapShed and the models folder. Here we have the other model that we're interested in, the UA viewer, the urban area viewer. We double click on this to click on run, and then we are presented with the urban area viewer. Again, let's minimize that form and take a look at the data that we just generated with the model within the urban area viewer. We do this by clicking on the Browse for Input File button, and we go to the same output folder that the GWLFE output was located in, and this time a different file is presented with a UA extension at the end. This type of file is used for the urban area viewer. It is also located in the output folder but has a different extension than the type of file that can be opened up by the GWLFE model. So we double click on this, and then model output information is presented in this particular form. As we can see, the urban area viewer is comprised of 4 different tabs: the Watershed Totals tab, the Municipality Loads tab, the Regulated Loads tab, and the Unregulated Loads tab. If we go back to the Watershed Totals tab, we can see that the information presented here is essentially the same as what we would see if we viewed the model output for this particular watershed in the GWLFE model using the average mean annual loads option. The difference is that this information is always presented in the English format, i.e. with acres and pounds. In addition, a loading rate, a unitary loading rate, is also calculated for sediment, nitrogen, phosphorus for each of the source areas. If we take a look at the value here, we have 5,251,272 pounds. This is essentially the same or pretty darn close to what we had calculated or viewed using the GWLFE model. In fact, I can open up that calculator that we used before and see that they're only a few pounds off. Essentially, this is due to rounding errors with the area and some of the loads, but in this case, it's less than 0.1% different. In addition to the watershed totals, we can also see the loads for any of the municipalities within this particular watershed using the Municipality Loads tab. These calculations were made using the urban area layer that we loaded into MapShed. In this particular watershed, in the Big Hollow, we have a couple of different townships or municipalities, including College Township, Ferguson Township, Patton Township, and State College Borough. For each of these areas, a load has been calculated using an urban area layer and the land use layer, as well as the loading rates that are calculated and have been included on the first form. So what we can do is go to any particular municipality and see what the load is from these different sources for sediment, nitrogen, phosphorus for that particular area. Again, these loads that you see here, total loads, are not necessarily for the entire municipality. Rather, they are for the urban area or the MS4 area within those municipalities. At this point, each of these loads is considered to be unregulated until we indicate otherwise. This is done using the Regulated Loads tab. So if I go to Patton Township and find the same municipality in the Regulated Loads tab, I need to indicate for each of these source areas how much of that load or how much of that area is contained within a regulated area. That is, if 100% of the urban area is going to be included in your watershed improvement plan to address the loads and come up with a plan for making load reductions, you would have to specify 100% of each of these areas. So, for example, for each of these source areas, I could indicate 100% of that area is going to be included within my plan. 100% of the load, corresponding load as well, will be addressed in the watershed improvement plan. And I'll do this quickly. And I do the same with these other source areas. In some cases, there's not a load associated, like with farm animals in this case, but I'll just type in 100% for each one for now. And you'll see that this load now, in this case for area, it's 2,199 acres. And I'll make it easy for the phosphorus load. That's 604.1. If I go back to the municipality load, that's the same as we see here, 2,199 acres, phosphorus load 604.1 pounds. So none of the source areas have been parsed out, if you will, of the municipality at this point. This can be done by providing a smaller percent regulated value in these cells. For example, if a particular township decides that it is only going to be responsible for maybe 50% of the cropland, maybe 25% of the forest, 50% of the hay pasture. Turfgrass usually refer to golf courses. I'll leave that 100. And generally you would take 100% of all of these other categories. But at this point, by making these values smaller, the load that needs to be addressed is now smaller. So before we started out with, for Patton Township, a load of 604.1 pounds. By parsing out some of the area, we now have a value of 584.3. I'm sorry, a load of 584.3. And the area that is now part of the plan is 1,900 acres as compared to the original value of 2,199 acres. So this is a way to parse out some of the area and loads for any given plan. When we do this kind of parsing, two things happen. First, the area and the loads for any given sub-area, if you will, in this case Patton Township, these loads are reduced relative to the starting loads. So these loads have not been changed, but we now have these regulated loads which are less than the starting loads. And a municipality may wish to use this load estimate for their plan. That is, they can choose to reduce a smaller load, but this does eliminate some options in terms of applying BMPs in certain areas, and sometimes it's an advantage and sometimes it's not. I won't go into the advantages and disadvantages in this training. I'll just say this is how that kind of parsing can be done with this form. Now, the other thing that happens is that when regulated loads are calculated, as we see here, these are then subtracted from the watershed total to provide a new total for unregulated loads. So again, if I go to, in this case, area, the starting area was 10,939 acres. I have now regulated a certain amount of the watershed, but left a fair amount unregulated. And so this 9,040 now represents the new total for unregulated loads within the watershed. And now we also have, well, I should say, this is the unregulated area. We now have new loads. These are the unregulated loads. And if you're to add these loads to the regulated loads, in this case for Patton Township, you would end up with the starting loads for sediment, nitrogen, and phosphorus. Okay, I'm going to go back to the regulated loads tab and set some of these values back to 100%. In other words, we're going to assume that we are going to address the entire urbanized area within our municipality in terms of watershed improvement plan development, and will not be parsing any of the loads out. And what we want to do is make sure that when we change these, that this value source area is the same as this new area. And I should just point out here that those values don't take unless you move to the next cell. So now we've reset everything back to 2,199 acres, and we have that original starting load that basically matches what we have on the municipality tab, the load tab. So essentially, these loads at the bottom represent our baseline loads, our newly calculated baseline loads for our municipality, more specifically for our urban area or MS4 area within our particular municipality. And these are loads that we are going to address as part of our improvement plan. And these are the loads that we are going to try to reduce using the BMP scenario editor in the GWLFE model in the next exercise. Okay, before we move on to the next exercise, the next unit, let me just briefly summarize what we've done up to this point using the PowerPoint presentation that I've developed. So we have used MapShed to create an input file for the entire Big Hollow watershed. We've also loaded the urban area layer as part of the MapShed analysis. Because of that, we have calculated a load not only for the entire Big Hollow watershed, but we've also calculated a load for the urbanized area, which we're assuming to represent the MS4 area within our township, Patton Township. So the load that we looked at in the urban area viewer for Patton Township represents the load originating from this particular area, colored in green here. The watershed total shows the loads for the entire Big Hollow watershed. In the urban area viewer, we can also see loads that have been calculated for 3 other urban areas, which don't necessarily pertain to us since we are only interested in calculating the loads from the MS4 area within Patton Township here. Now, for this analysis, we were constrained to using the urban area layer to represent our MS4 area within our township. In the next edition of MapShed, we will provide users the opportunity to load their own sewer shed or MS4 area instead of using the urban area layer that we provide as part of the MapShed download. This will allow the user to more definitively estimate what the pollutant loads are that are originating from their sewer shed, and they don't necessarily have to use our urban area layer. However, if the urban area is close to the sewer shed, I assume that you could probably use one or the other, but in many cases the sewer shed might look different than the urban area as shown here in this particular slide. Okay, at this point we are ready to move on to the next unit, in which we'll be calculating potential load reductions by implementing various BMPs in our urban area.